Welcome everyone. Very good to have you all here. Thank you for taking the time out of your busy schedules to be with us here today. I think today has, or rather is of particular significance to me because Standard Bank was my first bank. So I think the starting point of today has actually been probably from about 10 years ago when I got my first Student Achiever card. And I was the coolest kid in the block in high school. And I could, you guys enabled me to make some questionable life decisions. But yeah, as Angelo mentioned, I'm a head of data science at Pygio. I look after a lot of the product initiatives, data team, sort of, and speak to and think about really how we implement and enable our clients on the Snowflake platform. So a lot of that centered around assembly, sort of as the core go-to-market and central way of thinking about the way we deliver these projects and sort of capabilities and use cases to our customers. And I think the core sort of objective of my talk today is a little bit more technical, but I think it's to show a practical implementation and how really assembly manifests in a particular use case, right? So speaking to the particulars of the problem area, speaking to the particulars of actually how assembly sort of hits the ground running, right? So what we'll be focusing on sort of as a use case area is transactional monitoring for anti-money laundering, and I hope this clicker works. That's really cool. So I'll start off by framing the problem. I'll speak to some of the current approaches to transactional monitoring, what are some of the downstream issues of those. I'll speak to then, how we would think about this problem, taking the assembly approach, and then a little twist that we added on top of assembly and sort of what that is actually enabled through assembly, and Dimitri alluded to it, by using some clever data science techniques, which I think is a real indication of sort of the framework and the platform and the product in general. So, and then I'll end it off with a quite a cool practical demo as well. So, what is transactional monitoring? I obviously imagine that the audience is quite broad, across the bank, so not everyone is involved sort of in fraud and forensics. Ultimately, the goal of transactional monitoring is really to prevent illicit activities like money laundering and terrorism financing, right? So obviously it's a very, very critical use case for the bank, both from a regulatory perspective, both from obviously then downstream from a reputational perspective, as well as the impact that this problem has across Africa and the globe. So some of the estimates globally, or specifically to South Africa, is that there's about 80 billion rand laundered throughout South Africa on an annual basis. And I think as a hub of Africa, a lot of money comes down before it goes back up, to North America, to Europe, to Asia. So South Africa is sort of under a particular amount of scrutiny, and our regulators are obviously quite sophisticated and they've been clamping down quite a bit. The grey listing, obviously, that everyone will be aware of, being one of the key artifacts of that sort of clamping down. I'd say that obviously fines and penalties and slaps on the wrist are a very big problem. But as I mentioned earlier, the reputational damage of having your brand associated with specific, financing of terrorist groups or syndicates, around the world is of much greater consequence, right? I think Standard Bank is obviously one of the best brands in South Africa and Africa at large, and it's not really something that you'd want to be associated with. So I think one of the key artifacts though is that fraud and transactional monitoring do have quite a nuanced difference, in that fraud is really a rapid detection of isolated events, whereas transactional monitoring really speaks to more of a syndicated kind of sort of fraudulent activity over longer periods of time and over many groups of accounts, right? So it's inherently a slightly more difficult problem to tackle. And I think we can see that through the numbers, right? So just this year, Standard Bank was hit with a 13 million rand fine. As I mentioned, I don't necessarily think that 13 million rand is a number to Standard Bank Group is of particular materiality. But again, it also speaks to the downstream reputational problems, right? And there are second and third order consequences of this number. As you can see from this list, every single one of the tier one banks in the last decade have been hit with fines. Capitec of of most recent consequence hit with a 56 million rand fine by the PA. And in particular to Standard Bank, this fine that was pulled up, and the regulators, the Reserve Bank actually published the findings, was due to a massive backlog in these reports and alerts, as well as not being able to compile what's called suspicious activity reports or suspicious transaction reports, right? So these automated systems, the current sort of state of the art in what exists in the bank, will detect certain fraudulent activity, and then from there, forensics teams need to go and investigate and then compile these reports. And that's SLA'd under the regulator. They have to do that within a predetermined and specified amount of time. Now, why are these systems struggling? And actually, maybe I'll start off on the right side, right? So some more of these numbers in the most recent penalty was about 80,000 of these alerts not being reviewed within SLA periods, so 48 hours. So that speaks to many alarms and alerts being surfaced, the majority of those most likely being false positives, right? These STR and SAR reports, there's a massive backlog, right? So there's a 15-day deadline that the regulator mandates, and ultimately the bank needs to comply to those deadlines, right? So there's a massive backlog. Ultimately, this is not really a problem that you just throw more people at, right? And the current software systems are not assisting either. Why is that the case, right? So I think there's three key artifacts of this problem in particular. Is number one, fraud as a vector has a very high velocity. So these fraud syndicates are able to change and sort of counteract a lot of the AML sort of detection patterns that these banks, such as yourself, obviously put in place, right? And I think ultimately what that does is it leaves the bank on the back foot. Second of all, is there's an ever-growing amount of data, coming from core banking ledgers, mobile applications, IoT devices. Your CRM is ever increasing, and it's only ever getting bigger, right? I heard anecdotally that Standard Bank is actually generating on the order of 15 million transactions per day. So you can imagine that this becomes an inherently very difficult problem to manually investigate with more bodies and with more people. We do need software, and we need a new version and a new era of software to assist us in sort of handling this, right? And as I mentioned, ultimately the current systems are quite rigid in that they're rules-based, right? So they don't capture the sufficient complexity of these fraud syndicates and the patterns that are inherent and hidden within a lot of these patterned sort of fraud rings and accounts. So just maybe speaking to what are some of these current approaches, because I keep alluding to them, right? So the simplest is obviously a rules-based approach. That's, you can think of as a simple definition that either a business analyst, a forensics investigator would write in SQL or Python or JavaScript or any kind of programming language. The added benefit of these is that they're super simple, right? So they're easy to implement, very explainable, which obviously the regulator loves. But they obviously do suffer from specific amounts of cons, which are number one, the rigidity, as I mentioned. They're poor at detecting these complex schemes. And a very, very big problem, which we saw from the previous slide, is that they result in a very high false alarm rate, right? So if the tool is too blunt, you surface too many of these alerts, and then your fraud teams are completely inundated, right? As a data scientist, I obviously have to put the slide in. There's then the next version of this, which is narrow machine learning based detection methodologies. Machine learning, sort of at a very high level, takes two forms. The first being supervised, which requires a very high quality labeled data set of these kinds of fraudulent accounts or transactional patterns, which you then go and use to train a machine learning model, either being a tree-based method, a neural nets, whatever the case may be, to learn historical patterns to then go and obviously predict what's going to happen in the future. That's generally how inference works from a very narrow sense, right? The problem there being, as I mentioned, you've got a bottleneck and a dependency on these very high-quality labeled data sets, right? You can imagine the bank is probably sitting on the order of hundreds of billions, if not trillions of transactions. How many of these very cleanly labeled SAR reports do you think exist? Probably on the order of high tens, maybe low hundreds of thousands. So there's an inherent bottleneck, right, that sort of constrains supervised methods. You can then look to unsupervised methods, which basically say you feed in a whole lot of raw data to a neural net, and any kind of model. A variational autoencoder is a very, very sort of popular version of these kinds of models. And they sort of learn their own patterns, right? But the problem with this is that they're inherently inexplainable, and the way that it works is that you need to set a threshold, right? So they'll detect patterns, you'll then put a new kind of transaction through it, and it generally outputs a score between 0 and 1. It's pretty arbitrary, the point of threshold that you need to decide as a business team. And it's not really an explainable number because it's working and it's coming out of this black box. So it's not a number where I can say, okay, 9 or 0.9 is a 90% sort of like a confidence rate or detection accuracy rate. It doesn't really work like that, right? So there is an inherent amount of problems with the current sort of state of the art. We then said, okay, well, could we look at it from a different perspective? And obviously Dimitri mentioned assembly, which assembly, I think, speaks to two key concepts, right, that we try and capture in the framework. Number one is simplicity. So taking a lot of the complexity that's inherent in these systems, be it from a customer account and a transaction basis, coming from core ledgers, CRMs, OSS tools, BSS tools, whatever the case may be, and really simplifying that into the core business semantics, right? So simplicity is number one. And then number two, providing us with a templatized workflow to be able to then say, okay, well, what is required from an industry best practice to go and implement a transactional monitoring system? And Dimitri obviously alluded to the FIBO framework. The FIBO framework is an American-based ontology framework which we use. And as the partner to a lot of these use cases, our ultimate goal is to accelerate vision to value of these particular use cases. So through an ontological model of what's required in transactional monitoring, and I'll show exactly what this looks like, we can model the core concepts, their attributes as well as relationships. So in this case, really what you're looking at are customers, transactions, and accounts, right? It's probably a little bit difficult to see, but this is effectively what an ontological schema looks like from a bank's perspective. And I mean, this goes by many names. It goes by digital twins, it goes by business maps, but we as a partner are able to take these models out of the box and come to you as our clients, as our partners as well, and say, okay, from an opinionation perspective, from an industry best practice perspective, these are the out-of-the-box data artifacts that should be included in this use case. We can then obviously go and tailor them to the specifics of your workflows, of the business artifacts that are included already in these workflows, because again, we're coming into pre-existing processes, but then also be able to link that down to the physical data model that exists within Snowflake. So there's interoperability across concepts, and there's interoperability and connection to the actual physical data model that your analyst teams will allow. And what this does is, again, it accelerates a lot of vision to value for business analysts, machine learning modeling teams, as well as down the line will eventually be agentic AI, right? So the way you can think of these maps is that if you wanted an agentic AI system to be able to configure its own process and workflows, what assembly doubles up as is effectively a set of guardrails to be able to say, we as a bank have, according to sort of using a templatized FIBO framework ontology, customize that to our specific workflows. Let's just say it looks like this. The agentic AI would then be able to configure a specific set of workflows according to the frameworks that you as the bank have governed and defined, right? And obviously that provides a very, very hard set of guardrails for these systems. There are a lot of other artifacts that you could use assembly for. So retrieval-based tasks. If you wanted to ask a question about, on the top left, you can see there's the transaction node. You can see all of the attributes that are related to it, but then all of the core concepts that are related to it as well. So you could ask a question through Snowflake Intelligence. We can most likely show this as a demo. And what will happen is that the agent will be able to traverse and reason throughout this business map that you've defined as the bank, right? So it's providing many different use cases. There's accelerated value delivery. There's a set of guardrails, as well as then there's also a business structure through which, even human teams, but then obviously down the line, agentic systems can obviously leverage. One of the nice artifacts of using assembly is that it inherently, as I mentioned, it models the concepts, attributes, and relationships of core business entities and concepts, right? So what that does is it sort of has an inherent graph-based architecture, and graphs in general are actually used quite a bit throughout the banking and financial services industry. The reason why graphs are actually quite a good way to model this kind of problem and create, as I mentioned in the beginning, some people call them digital twins, effectively model the digital twin of your bank is because they inherently model entities and relationships, right? So what is the relationship between a customer, his accounts, and the transactions that come from and to that account? And I'll show an exact example of what this looks like within Snowflake. We've actually built a data model, which I'll demo in a bit. This relational structure is obviously quite highly expressive in detecting patterns. And remember what I said earlier in the beginning, is that with transactional monitoring, these kinds of schemes and these kinds of fraud patterns are actually committed over long periods of time and over many, many accounts, right? And there's multiple hidden layers that exist. What using a graph-based architecture allows you to do is to actually model those interdependencies, and because generally it's not what's happening with your accounts, and running analytics on your single account can only get you so far. What graphs allow you to do is actually model the behavior that's happening around you, as well as within the communities, and then that will propagate back into your account, and obviously then you can risk score, again, based on these specific kinds of communities. And then I think maybe the last artifact to note, which is quite nice, and I'll show another example of this in the demo, is inherent traceability, right? So if you've got a machine learning based system which has detected a specific account, you can represent that account and its transactions and all of its interrelated counterparties through this graph-based architecture, which provides you with a traceable sort of audit log to your forensics teams and investigators to be able to go and ask very specific questions. Again, you can extend this to agentic AI, and to my understanding, we're one of the only partners in the world that have actually developed a custom-made MCP server which can actually write custom Cypher queries, which Cypher is almost like, I don't know if anyone's worked with Neo4j or any kind of graph-based database. But we've actually written an agent where the same way you could write natural language queries and convert it to SQL for structured databases, we can actually write natural language queries and convert it to almost graph relational queries, right? So you guys are probably thinking to yourselves, this looks very complex to me. It's exactly the same as Snowflake Intelligence. And we'll actually show an example of how this works. Some industry references, I'm always of the belief that you should be very skeptical of someone who comes up and says they've just developed their own methodology and there's no precedent. JP Morgan's also on this list, but they used sort of a variation of graphs. But both MasterCard and HSBC have used graphs quite successfully in their anti-money laundering and fraud endeavors and forensics exercises. One of our PhD data scientists actually worked at PayPal, and they also went from using a rules-based system to implementing a graph neural net-based detection model, and again, blowing sort of the previous rules-based methodology out of the water. So, what I'm going to show today is how assembly allowed us to model the problem, sort of create a digital twin of the bank, which is again graph native, and it provides you with a particular structure which allows you to really exploit the expressiveness of those interrelationships between all of your different customers, their accounts and transactions. But then we said, okay, well, can we actually showcase the true power of Snowflake as a platform as well? Because again, it's a platform of infinite compute, infinite scale. So can we actually try and leverage that compute and scale and effectively develop a methodology which, again, probably yields state-of-the-art results. So we looked at sort of the industry at large, and we wanted to see who the masters of scale are. And if you look from an AI or machine learning perspective, sort of the best example and use case of practical scale and compute of data compute and data, is transformers, large language models, right? We are likened, and we were actually quite inspired what is called self-supervised learning in these transformer architectures. So what self-supervised learning very, very basically is you can take whole amount of data, you can feed it into this model, and the labels that the model will actually train itself through the data that's inherent. So if you think of transformers, the way it works is you've got a list or string of words, and basically we hide the last word, and all we do is we ask it to predict that last word. It makes a prediction, it'll say cat, then it will show it's actually dog, and then it calculates a mathematical distance between the two, which again is all sort of represented in this vector space, and then that back propagates. You do that a couple billion times, and you get models who understand the rich semantics of text, as well as what a ChatGPT does, and obviously they're quite performant models. I'm sure everyone in the room can vouch for actually how useful these models are. That's really how pre-training works, and what that allows us to do is really scale sort of the paradigm of training these models, right? So again, we're not dependent on human labeled data to have to train supervised models. We can use self-supervision to unlock scale. Now you can think of the example that I gave earlier where now the bank is sitting on the order of trillions of transactions. We're sort of getting to a paradigm by which we can actually unlock that amount of scale. Generally, obviously the idea here is that through this pre-training phase, these transformers, as I mentioned, you know, they learn the sort of semantics of language, different concepts, people, their interrelationships. But then we said, can we do the same in the banking context, right? So can we, instead of modeling words as tokens, can we model accounts, customers, and transactions as these tokens, using the graph-based architecture that Assembly provides to us, and unlock a form of self-supervision. So, you know, we also went back out because, as I mentioned, you don't want to look at someone who's purporting to have to develop their own, you know, methodology or using something for the first time. You should look for certain validation markers. And what we found was quite interesting is that Stripe have actually done a version of this. So they're sitting on also, probably you can imagine, hundreds of billions, if not trillions of transactions. They used a form of transformer-based self-supervision to actually model transactions as words, right? So they went and unlocked, and what they did was they tried to use this representation that the model develops over learning and sort of droving through so many transactions, using that rich representation that it develops to then go and then calibrate into specific use cases, right? And what they did was they used it for what's called card testing, which is a form of fraud. It doubled their detection accuracy overnight, right? By using these transformer-based representations, which was completely unsupervised. They basically fed the data in, scaled the compute, and they just represented the data in the correct way. We obviously want to do the same. And another thing that's quite interesting is that we found is that by modeling sort of the bank twin, right, and doing a set of scenario forecasting and modeling of trying to predict different elements of the bank, and basically doing that multi-billions of times through a methodology called contrastive graph learning, which I won't really get into the details now because I think it's quite complex. You can actually use these representations across multiple different use cases. So what you can think of it is now you've got a digital twin of the bank. You've trained this massive graph model to learn behavioral patterns across all of your customers and accounts that scale to quite a few trillions of transactions. And what you actually get is a very rich representation, effectively a world model that's learned the semantics, the rich meaning, the rich behavior of everything that's going on within your bank. What we're seeing in the industry, which is quite an interesting paradigm, is that you can use those rich representations for many downstream use cases, right? So be it fraud, be it credit, be it card ops, be it payment ops, be it product recommendation, we're finding that these representations that these massive models are learning can actually be used for many obviously downstream adjacent use cases, right? All you need is a small calibrated data set or sort of quality label data set for the particular use case in hand. So then we basically did this. So you can think of self-supervision analogous to pre-training large language models. We did that, and out of the box, without providing any labels, you could see, so I don't know how well you can see this graph, but the purple dots, sorry, the orange dots are fraudulent transactions, and the blue dots are non-fraudulent transactions. This is without giving it any context or any labeled transactions as to what is or is not. So you can actually already see that through just looking at bank transactional behavior, through this, we use the particular open source transactional data set, without giving it any meaning, the bank actually learns its own segmentation rules to basically group populations together. You can then take that very rich representation and then feed it through this very highly calibrated data set of actual labeled fraudulent transactions, right? So you can take either SAR reports, or you can take confirmed accounts which have been locked down for AML sort of infringements, and then you can really calibrate it as a downstream scorer. And then again, there are a couple additional artifacts of that. You can break out pre-training, which is obviously very heavy and it's compute intensive, to then inference, which can be very lightweight and quick. As I mentioned, that calibration exercise is analogous to RLHF. So, our reinforcement learning from human feedback, the way that they actually get that next token prediction model to become actually a useful chat assistant, is analogous to the sort of the exercise that we did through this final fine-tuning stage. And I mean, we think that this is obviously quite an exciting approach. We think that this is the results that this yielded, which I'll showcase in a second, are really state-of-the-art. And there have been quite a few research papers that have been published around the world using this kind of architecture, but no one using self-supervision, and especially on graph architectures modeling this kind of behavior that we've seen. And I think maybe the final artifact that we had listed was that we thought of this almost as the ChatGPT moment for anti-money laundering, right? So if you think about, a human analyst, maybe by analogy, if you said to them, okay, well, write me a set of rules to pick up a human's name in the sentence, right? Very, very simple natural language processing problem. It's actually very difficult for us as humans to formulate those rules. No question. Anyone would just use a large language model. They'd feed the sentence into an LLM and they'd say, please detect and sort of extract name entity recognition problem, extract all of the names that exist in the sentence. You wouldn't even think of writing regex rules, because where do you even start? It's very difficult, and our brains actually aren't wired to approach the problem in this kind of way. Our perspective is that through this ChatGPT moment for AML, is that the way in which we look at sort of rules-based transactional monitoring systems will be the exact same way in which we look at regex rules or hard, rigid rules for natural language processing. And you would actually use this kind of assembly-based architecture to sort of solve this problem. So, enough for the slides. I hope everyone's still with me. I hope my Snowflake instance is also still with me. So now it's demo time. Cool. I hope this doesn't lag. Great. So what I wanted to show everyone was basically a practical implementation of what this looks like. So let me see if I can actually expand this to a full screen. Right, so what we did was, as I mentioned, we went out and we procured our own data set of accounts and customer transactions. As you can see, that we basically sampled a few community clusters, which Assembly basically clustered for us out of the box and basically grouped these accounts and these account groupings based on certain behaviors out of the box, right? So we took it in, we put it into the framework, and out of the box it basically said there's some kind of interrelationship and there's some kind of risk-based approach that we need to start taking to this investigation. Which again, from my time as being an actuary, you'll find that a lot of these fraud and forensics teams won't go and just look at every single false alarm or rather alert that's been generated at once. They'll try and take a risk-based approach, right? So they'll take your most high risk or sort of high anomaly or high alert or high criticality sets or groups of transactions. You'd start there and then you'd move down, obviously to prioritize the investigation process and be a little bit more efficient with one's time. It basically created risk categories for us, as well as then risk narratives for us. So explainability narratives to then say, this is a large cluster with substantial total transactions flowing out, far exceeding incoming amounts. And this is for community 104, right? So I can go out and I can zoom and I can try to find community 104, right? So that's this one. right? So it inherently found that there was some kind of relationship here, potentially UBO, right? So there's the same account holder, potentially it's the same ultimate beneficial owner who's got multiple accounts, and they're making transactions and payments through multiple intermediaries. I won't go into this in too much detail, but then again, you can see that for the purposes of our fraud teams, this provides us with out-of-the-box capability and out-of-the-box functionality to be able to say, okay, let's start off with the most high-risk fraud communities. We then said, okay, cool. Well, let's showcase and let's try and test, because as any kind of data science exercise, you want to benchmark your approaches, right? So you'll see that with any of these foundation model labs, when they release the newest version of GPT 4.5 and GPT 5, they've got a specific set of benchmarks, right, that they evaluate each other off against. And it's sort of like an internal kind of competition, but it's a great way to be able to compare your results with previous sort of industry-based practices or standard approaches, right? And you'll read most research papers as well. They will always provide analysis of what their approach did compared to pre-existing methodologies. So we then started off with a very, very basic rules-based approach. What we did was we wrote this actually in the form of SQL queries. So we'll show how actually it starts off quite simple. But this rule in particular that we wanted to showcase was, if a customer deposits cash transactions at multiple branches or ATMs within a short time window, and the total sum exceeds 10,000, the account is flagged for potential structuring, which is a particular kind of fraud topology for money laundering, right? What Assembly did was it pulled up all of the accounts. We picked one in particular just for demo purposes, and then we pulled up all of the summary statistics. So what's nice about this, and what I'm actually showcasing you, those who haven't seen this before, but these are built-in dashboards within Snowflake. So no Power BI, extra Power BI licenses needed. This is based off a framework called Streamlit. Super easy to use. It comes out of the box and basically links again to the particular data models that we're trying to investigate. Right, so the fraud team has run this rule. We've picked up 20 accounts out of the last batch, and he wants to go and investigate one. Based on this rule, he can actually go in, and as I mentioned, you've got a lot more and transparent sort of auditability of these traces. So he can click into this account, he can look at the different flows, he can actually find the final traceability. But again, this is quite simple, right? Because as you can see, how many accounts that we've detected, the alarm rate and the alert rate is going to be quite high. And there's already an inundation of a lot of these alerts, right? So then we said to ourselves, how can we actually take the rich structure and expressiveness of this graph, the sort of the way in which they model these relationships out of the box into account, right? To then actually go and try and find some particular kinds of fraud topologies that we find in practice, right? So one of those are circular transactions or short cycles. So basically what this is saying is that if a person makes a transaction and that money or money flow goes through multiple intermediary accounts and actually comes back to that person, we want to know who those accounts are, right? Because again, they do many clever kinds of structuring sort of schemes, and I think that's the way that they actually get a lot of money out of the account, out of countries or certain jurisdictions. What you'll find here is that we just highlighted two particular accounts in general. So natively out of the box, Assembly went and actually picked up particular cycles over certain periods of time. We ran the rule, which again is very deterministic, that our analysts had to devise and think up on based off research that they had done, and they said, okay, well, cool, we know that circular transactions are a particular kind of fraud topology, let's go and try and find them, right? So they ran the script, and we found a very, very tightly found, a very clearly defined kind of this kind of fraudulent behavior taking place. We did the same for a particular kind of sort of fraud, also called transaction chains with value decay. So this is a particular kind of AML whereby a single account will make multiple transactions. Generally, they own all of the intermediary accounts, but what they do is they drop the amounts that they deposit sort of by a factor of 5, 10, and 20%, right? So it looks like they're actually making multiple payment transactions, but it's actually all through to the same UBO, right? And you can see that these chains actually exist natively, right? So we actually picked up 3 of these accounts. But again, as I mentioned, we've got now a much more expressive way of picking up these rules. We've got a much better way of doing the analysis and triage of this AML, this particular kind of AML. But writing these rules is still quite arbitrary, right? So, analysts still have to go out. Generally, it's based on expert heuristics. You're dependent on the person and the experience that they've had. And I think there's obviously a lot of trust that goes into it. But as I mentioned, there's any amount or combination of these rules or thresholds that are related to these rules that can take place, right? So we then said, why don't we get, using this version of self-supervision, a graph neural net, a transformer-based architecture, but it's actually neural net-based graph architecture, to actually do this rule discovery for us, right? And what we then did was, obviously, it went and it learned these rules, and basically what it did was it crafted its own decision boundaries. So as I showed in the slides previously, and I don't know if this side can actually see, but out of the box, from a purely unsupervised perspective, we can see that the graph neural net is actually learning certain risk clusters out of the box. So orange being sort of the two clusters in the top right, and then blue obviously being everything else, right? So you can see that through this rich representation, it's starting to say, well, actually blue, this normal behavior sort of looks like that, and we're going to cluster that into one set of accounts, and then the red, which sort of looks abnormal, but we don't know yet what it is, should be clustered separately, right? It doesn't know inherently that these are fraudulent accounts, but all it knows is that the behavior inherent to these accounts is sort of abnormal. We then obviously went and benchmarked, so we took a standard data set of about 100,000 transactions, and we wanted to test our approach, right? So we said, the static-based rules, which typically your analysts would write as SQL queries. Then we said, okay, well, can we enhance those with more complexity using the graph-based rules? And then we said, okay, well, can we then compare that to this graph neural net, which then would output specific kinds of embeddings, and then, as I mentioned, we did a small fine-tuning exercise at the end. And then could we actually combine the two? Because who are we to come into an institution like Standard Bank and say, you need to rip and replace every single one of your rules-based methodologies? We want a lot of the models and the methodologies that we sort of can impart and obviously assist you guys with to be quite complementary. And from the results at the bottom, again, I'm not sure how clear this will be for everyone to read, but on the far left, we have the static rules. The most important of these charts to see is the bottom left, right? So F1 is a common data science sort of coefficient of discrimination, right? So it measures how well your model is discriminating fraudulent versus non-fraudulent sort of accounts and transactions. And generally this is used to benchmark different kinds of classification methodologies. What we found that the number, you don't have to worry about the particular number, it's all relative to the data set that we use. But for the static rules, we had a score of 0.12. So, fairly good, but we really don't know how good that is. And again, we could have an arbitrary number of these rules, and it's pretty difficult to just keep adding them, right? When we increase the complexity and we take the graph structure into account, that jumps by about 50% to 0.17. We then said, okay, well, let's benchmark the graph neural net, right? Using not handcrafted rules, nothing that a human being has actually written themselves or devised themselves. Because again, you could do prior research, as I mentioned in the beginning, the velocity of the fraud vector is quite high. So generally these schemes are constantly changing over time. So if you're doing historical research, by definition, you're going to be out of date and you're not going to be able to catch these kinds of behaviors. Whereas a machine learning model won't really look at it the same way. They'll just say very, very deeply and on an interconnected basis, this doesn't look right. I think we should segment that and investigate it. And that's sort of how we get to these maps. We then tested that, and we went from 0.17 and 0.12 to 0.64, which is almost 4 to 5x improvements of prior methodologies, right? Not 40 to 50, 4 to 5x improvements, right? And it just shows you sort of the richness that when, again, you use a graph-based way of representing these digital twins of banks, you use the scale that modern sort of machine learning-based algorithms and architectures allow with the help of a platform like Snowflake. And when you combine all of these three things together, you can get something like ChatGPT, but then you can also get really, really improved sort of detection results. And then the final one is sort of a combination of the two. So as I mentioned, we're not here to come in and upend your current processes. we want this GNN-based model or machine learning-based model to live alongside the rules that your teams are currently devising. Maybe put one in another way, is we want to look at, because remember in the slides that I'd shown you, false alarms and false negatives are two things that you need to look at quite separately, right? The Reserve Bank fined Standard Bank because of the amounts of alarms that they hadn't looked at, right? And just because of the inundation and sort of just the sheer volume that had come through the system. What we then went and did to make it quite practical is we modeled per 100 accounts that we're monitoring and detecting, how many false alarms came up, right? So from your static rules is about an 8.2 out of 100. Sorry, that's 4.1 out of 100. And then we almost halved that to 1.9. So if you go back to sort of the regulatory thing, out of the box, we're halving sort of the number of investigations that need to take place. Conversely, which is actually a little bit more important, which speaks to recall from a data science perspective, or your false negatives, right? So those are the accounts and transactions that go hidden under sort of the rug so that you actually don't detect. That speaks to the reputational problem, right? So that's actually what happens when you don't detect a truly fraudulent account, and that's when a lot of the downstream issues come up. We went from 8.2 out of 100 with the static rules all the way down to 3.5. So a more than half improvements, or sort of rather 50% improvements of these results. So overall, you're improving detection accuracy, you're getting fewer false alarms, and you're actually detecting a lot more of these false negatives, right, or reducing the number of false negatives. So obviously that's generally quite beneficial. I think it showcases many of the different capabilities. It showcases assembly. It showcases the kinds of sort of frameworks and out of the box artifacts that the actual ontological framework provides us with. It provides us with a view as to how valuable using graph-based architecture is. Finally, how if you scale up these kinds of compute paradigms, you can actually get orders of magnitude better results and improvements. But we didn't end there. One final thing that we did, because again we were quite concerned with the number of SAR reports that were being generated, and it was something that we obviously wanted to address head on. We said, well, surely the guys at Snowflake have developed a piece of tech that can help us with this, right? So let's just say this pipeline it works and it detects a particular account, either using a rules-based approach or a machine learning-based approach. We want to now go and actually automate the SAR or SAR report generation process, right? So what we did, and I really hope this works, but we integrated Snowflake Intelligence, and we created our own custom AML pipeline agent, which had access to many of the tools that we had written, right? So what it could do is it could reference the underlying physical data model, it could reference the graph ontology, it could reference all of the machine learning models that we had linked to it, as well as the rules-based approaches, as well as further downstream explainability models, which do post hoc analysis, which basically provides some kind of sort of feature importance or explainability per level of detection, right? So let's just say we had run through an example, and in the dashboard we had found that we want to investigate this account, right? 100428660, right? We don't want to have to write the SAR reports by ourselves. Now, another nice thing about Snowflake Intelligence is that you can give it particular report templates that you'd like it to conform to. So the Reserve Bank has their particular set of metrics and inputs that they require this report and the structure that they require this report to conform to, and obviously by extension the number of data artifacts that are included. We included all of that out of the box within this report template. So all of the data artifacts, all of the report structure. So I'm just gonna quickly run. So what I said was generate a SAR report for account 82230CE40. What it will do is, based on sort of the template that we've provided, we've said, okay, these are the key areas that you need to go and run your analysis and triage. It then goes in, and per step that it's been told to execute on, and per sort of structured area of the report, it will go and execute specific SQL queries and Cypher queries, obviously by extension. And as you can see, this basically speaks to chain of thought modeling and reasoning. Another nice thing is that we can integrate, and through the integration of Snowflake intelligence with Assembly's ontological model, again, now the model understands the interrelationships between this account. It can actually traverse the map and it can see all of the other accounts that it's linked to. It can summarize all of the transactions that it's sort of associated with, and then it can bring all of those together into one consolidated report. And it sort of continuously runs all of these things. It plans the next steps. Generally, you would have this as an automated process, right? So you'd have your AML pipeline run, and depending on certain confidence scores, you'd say, okay, well, if it's over 80% confidence, and we pretty much know that this is something that we want to investigate, you can actually have the model automatically go and craft these reports, which then get saved back to your Snowflake physical data model. The nice thing about this is that Snowflake also provides very good and comprehensive data sharing capabilities, right? So you can actually out of the box natively share sort of a view, materialized view back to the Reserve Bank and back to the regulator. So obviously it's all access controlled, it's all governed through Horizon. So the advantage and the benefit of that is that there's no Excel spreadsheets, there's no sort of zip files and emails and SFTP links going out, of these reports, right? Obviously, it's gone and done all of its thinking and it's executed all of its steps, and you can see here that it's generated a full suspicious activity report for this account, right? So it gives a nice account overview. It says, okay, obviously, we've seen some high value transactions ranging from this value to that value, mainly in pounds, predominant use of UK pounds, heavy reliance on ACH payment formats. Then it will run through an analysis of all of the different models that ran. So as I said, within a hybrid architecture, you'll have rules, you'll have graph-based approaches, you'll have static rules. It will run through all of them and we'll see which one of those models hit and which ones obviously flagged it. Then you can obviously go and do a further detailed analysis of what the thought was important. So there's feature importance and explainability. So being a machine learning based model, you'd want out of the box, these models to say, okay, well, we flagged this account. These were the key features and these were the reasons why the machine learning model said that this was important. So out of the box, we've included explainability metrics, cluster analysis, as I mentioned earlier, right at the top. We can speak about the community that it's part of. So not only about that account in particular, but we're giving sort of community level information to say like, this is quite high risk, and we can include these sort of community, these risk analyses, narratives inside this SAR report as well. And then ultimately, it needs to give us a recommendation. So it'll say, we believe that obviously this risk assessment is quite high. It gives you the list of justifications, and then it'll recommend action. So I really hope this wouldn't be my account, but immediate account review and enhanced due diligence, investigation, and obviously you can specify these steps according to the SOPs that exist within the bank. So I think that's it. There was a lot that I covered. I hope a lot of that did make sense. I think that maybe one thing that I'd like to leave you all with is that one thing that I've found in my years of data science and consulting to many companies is that they underestimate the value that these kinds of technologies will bring to their businesses, but they overestimate how quickly they can deliver and get these technologies operational and the amount of work that will go into making these technologies operational, right? So our framing for Assembly is really more of a partnership. It's to say, let's start small. We can define specific use cases within the bank. We can pull off these industry best practice data models. We can define exactly what data assets are required, link it to the data that exists. We can obviously move it in. But then over time, the idea is that Assembly as a twin of the bank, as a map of the bank, will constantly improve as you guys keep adding business processes to it, as you keep adding new data artifacts to it, as new entities pop up and new sort of relationships get resolved. It's sort of a journey that we'd like to walk with you guys. So very excited to be presenting this. I think this is the world debut of Assembly. No one has seen this. I think, apart from our team. But once again, thank you all for the time. Really appreciate it, and looking forward to the conversation afterwards. I think if there are any questions, please. I'm sure there are quite a few questions.
As always, any questions? a hand over there. Can somebody got a mic over there? Well, there we go. Somebody's got a mic.
Yes. Hi. So my question is, given that our customer and transaction data may have data quality issues, so how do we ensure that this don't impact the training of the model?
It's a great question. So I think obviously data quality is super topical. It's one of the key sort of steps within the assembly framework. So Dimitri showed a slide deck. Obviously, we'll import all of the source data coming from all of your source systems of record, be it ERP, be it CRM, be it sort of a transactional ledger, core transactional ledger. There's a lot of out-of-the-box functionality that our team will do in terms of refining that data. So it's actually a set of steps that we take before, but it's a great question because we've developed a lot of our own IP which sits on top of and within Snowflake. So if you look at their Horizon framework, as data is coming in through these ETL pipelines, we're autonomously cleaning the data as it hits the landing zone within Snowflake, or again, there's some additional transformation that takes place. But what's also really exciting is that we're seeing the integration of AI agents within Horizon itself, right? So you as a human analyst don't have to, again, write arbitrary rules. You can just basically, specify certain guardrails and certain standards that you'd like all of your core master data and, by association or downstream transactional data, which is derived off of that, to follow. And you have these agents which in real time will monitor this information. Now, again, you'd want to use the deterministic software that exists. And again, this is something that I think Rolf and Kirsten can speak to much better. But data quality really is a core focus area before you get into starting. So what I've presented today is also multiple layers of abstraction. As I mentioned, with the underestimation of the amount of work that goes into it, getting data in and really getting quality out of that data is of the first set of intermediate steps that need to take place before you can embark on a journey like assembly. But again, it's one that obviously we can help you with.
Another question from the back. I'm going to assume that Snowflake has an OCR capability or technology. So let's say I want to build a solution where, let's say, through a KYC or onboarding process, clients are providing me with documents that I need to scan image to text, and then I want to use the transactional monitoring just to see if I can pick up anomalies. As an example, I got, let's say, financial statements from a client or an entity. Then I want to use also like transactional monitoring just to see if I can pick up any anomalies, whether I want to do fraud detection. Can I build maybe a solution like that?
Also a great question. So I think it's also one of the exciting things that we're seeing is that through using, and I'll sort of come at it from another angle, is that through using this kind of ontological framework, as I mentioned, it's an opinionated framework around if you have a specific entity, such as a customer, right? The bank needs to define a common vocabulary of what does a customer mean and what are the common attributes that customer needs to have, right? And I think that's super important because obviously it ensures governance, it ensures compliance. It also, very importantly, allows interoperability across the bank, right? So you won't have CIB using an example of, a definition of a customer that's different to PPB as an example, right? So that's super important. To answer the question directly, Snowflake does, yes, have OCR capabilities. What we're able to do though is with assembly, which is also super exciting, is that we can structure that unstructured data, and through having these LLMs, trace over all of the information that will come out of. So, as an example, the OCR model will run, it will pull all of the text off the key page, and it will say, okay, based on the common definition and the attributes that exist within this customer entity within assembly, in this common definition, I need these 5 attributes, right? As a first set of data validation, you can have assembly basically act as that sort of first step of defense, but then definitely, if anything is missing, you could use the framework to then obviously go and do downstream monitoring and alerting, right? So it could flag an account to say, well, something doesn't look right or a piece of information is missing. So definitely you can. And obviously it leverages both the tech as well as the framework.
I just want to ask around the false positives. How do you actually strike a balance between profit, reducing fraud, and also the customer ripple effect in the long run? Suppose the alert comes at the back of maybe a card that one call that gets made to the customer says, you need to block that card, you need to close that card. I mean, we're heading for festives now. It means that person may not transact for a reasonable period of time. Others misunderstand that call for a data breach. So how do we factor all that into reducing those calls?
I think it's a great question as well. So across any one of these systems, right, you've got basically a trade-off between generalizability, right, the model basically being able to speak to and understand various different sort of characteristics across your population. This is a very classic data science problem, as well as then, accuracy of specific groups, right? So you're always going to have a trade-off between the two. I think it's obviously dependent on what's important. So as I mentioned, to the bank, potentially, reputational risk is a lot more important to them. So you'd really want to focus on recall over your precision, as an example. But then ultimately, as I mentioned, and as we showed in the results, a combination of the two works best, right? So you want to leverage sort of the state-of-the-art in your algorithmic advances using something like a GNN or a transformer or machine learning-based approach, which scales quite well, which we showed. But then to your point, understanding specific characteristics about your customer, right? So it's happened to me actually many times where, I've gone overseas, I've notified my bank, and it actually isn't you guys because I've got two banks. I still have my student achiever, just by the way, but don't tell anyone. But I've gone overseas, I've told my bank, and they still block my card, right? Which is super annoying, and it keeps happening 2 or 3 times when they've actually unblocked it and then it blocks again, right? So that's where a combination of understanding your customer base, having certain policies and rules in place, and I think that your question speaks great to the example that we showed. So, having that good human understanding and context of the customers, which you can write those hard set of rules in, but then also having a machine learning based approach to actually help and augment, but then ultimately defining what's the most important for the particular use case, right? As I said, is precision more important? Is recall more important? Is blocking these transactions? Is the reputational risk more of a problem? So I think it's multifaceted, but again, that's something that you probably most likely have to define per use case. There's no cut and dry answer for how it would work.
Just a question. So today we learned the benefits of Snowflake and what it gives us. But your model is inherently very related to graph database and graph store. So why choose a database technology that's not a graph database versus a traditional graph database technology?
Is the question, sorry, maybe if you could just repeat it?
So why use Snowflake over traditional graph database technology?
No, great question. So we use both to answer the question. So assembly needs the physical data model of which to be populated and hydrated. Again, I think assembly provides us with a framework which we can use to accelerate certain use cases out of the box, right? So as I mentioned, you'd want to, through this 5O framework, which we showcased, right? You'd want to say, okay, to perform transactional monitoring as an example, what are the specific data products and artifacts we need, and what is the opinionation around how they relate to each other? Cool. We've then stipulated that. We will then obviously link that to the data which exists within Snowflake. So the way that it actually works is further abstraction, out of the box capability and functionality. And again, this is our value as a partner, where we have an opinion around how a specific use case. There's nothing worse than a consultancy walking into the room and sitting down with you as the business owner or the process owner and saying, tell me about your problems. There's absolutely nothing worse, right? You want partners who have an opinion and who can obviously go and leverage best practices. So the answer is both. You need Snowflake in order for assembly to work. Really, all assembly does is it provides that out-of-the-box opinionation around specific use cases and how it should work, how certain business processes should also run, but then providing you with different levels of representation of data throughout the stack, which a single agent can then go and reference the physical data model, which lives within Snowflake, but then also that abstracted layer, which speaks more to the business semantics and the context. So you'd use both to answer the question.
There's a question just at the front, and then one more there as well.
Good afternoon. Thank you for a great presentation. My question is more predominantly from a privacy perspective. I understand using machine learning models for AML purpose finds its justification in terms of PIA, and this is obligated by law. But I'm more concerned around further processing of the same information to create digital prints. Are we not in violation of privacy requirements in terms of further processing requirements?
No. So again, I mean, the Snowflake ontology basically leverages off the data that already exists within Snowflake, right? So from a data privacy perspective, Assembly is actually populated and governed by Horizon in the same sets of policies that you'd stipulate as a bank. So no, I mean, not out of the box. I wouldn't say. If that is the understanding of the question. Can I answer your question? No.
Because basically, remember the information will be collected purely for an AML purpose.
Correct.
And to verify the client.
Yes.
But the very same data set is further processed to create digital twins.
Yes.
And without, and for me, that falls within further processing limitation. So the information shouldn't be processed over and above the purpose in which it would have been collected for.
Yeah, I mean, you can think of, I understand the question now. So the data will only ever be available to the teams that otherwise would have. So your AML team, I mean, it's not going to be exposed to other sort of sets of business units or departments or teams. The way you can really think about it is in constructing the ontological, well, through that digital twin, through the ontological framework, you're basically just feature engineering, right? So it's the same thing as a data scientist taking up the raw data, right, generating some features and creating a different kind of representation of the data sets. So it's quite similar actually to a traditional data science approach. We've just found a way to accelerate it and actually, as I mentioned, provide some kind of best practice and structure around how the features should work, what their relationships should be, and what that data model should look like.
But the processing activities are different because the initial one is for AML compliance, and the second processing to create.
Just a quick, no, we're going to have to move on to the next session in a moment. So whether or not we want to, we'll add on to this, and then after this we'll move swiftly on. So I want you guys to make sure you have a nice long lunch.
Sorry folks, got nothing to do with Snowflake. I'm here to learn as well. But from a legislative point of view, one thing we need to remember, when we are dealing with custom information, the context in which it is done is within a confined area of people that have been given the authority to do with that data as they please. Now, as they please is dependent on what authority they've given a certain that group of people to perform with that data. The legislation also says that when an organization is going to use data, particularly copy, you can follow up on that. When you use data for its original intended purpose, and there are other purposes for which you use it for, you have to disclose it up front when you collect it from the customer. If you do that, you're well within your rights to do what the guys are doing. Okay, so that's the context that we need to see it from. But if we had a different view of, we wanted to do money laundering ourselves and we were a syndicate think the opposite.
Thank you.
Thanks. I know there are a couple of other hands. If we can put those questions to lunch or just when we're all kind of mingling, that's great. We'll make best use of the structured time.
Thank you, guys.
Nick.
Thank you.